Elizabeth Line. The beginning of monumental transformation, making London faster, more efficient, and more sustainable. The Elizabeth Line stretches from Royal Lock in the west to Plumstead in the east, covering a total of 100 km and passing through 31 stations via 32 km of newly constructed tunnels. Among these, 10 are newly built stations, while the remaining 31 are upgraded existing stations. The new tunnels start at Royal Lock Porter, passing through key locations such as Farringdon, Liverpool Street, Whitechapel, and Isle of Dogs, before reaching Victoria Dock and Pudding Mill Lane. The construction of the new tunnel was carried out through 10 distinct drives and 3 main work sites. Each drive refers to a specific section of excavation undertaken by a tunnel boring machine, while the main work sites serve as central hubs where TBM operations commence. The original plan included 16 drives and 5 land sites, but it was revised before construction began. Since Olympic construction was taking place at the same time, adjustments were made to avoid disrupting its progress and minimize the impact on existing areas. As a result, a new, more efficient route was developed, which improved the tunneling process. The changes not only reduced conflicts with Olympic construction, but also eliminated the need for the TBM lunch at Hambury Street shaft, and ultimately preserved the historic Britannia House, making its demolition unnecessary. The Elizabeth Line consists of a combination of existing railway tracks and newly excavated tunnels using the TBM method. The existing tracks make up the western section and part of the eastern section of the overall Elizabeth Line route. Now, let's look at the newly excavated tunnels. For each route segment, between the start and end point, 2 parallel tunnels were required, one for trains traveling in each direction. The newly built tunnels extend from Paddington in the west to Abbey Wood in the east, each spanning 21 km, totaling 42 km of new tunnels. The TBM method was predominantly used, but in some sections where TBM was not feasible, the sprayed concrete lining method was applied. This involved excavation followed by reinforcement with shotcrete. One of the stations with a route built using the TBM method is Canary Wharf Station. As mentioned earlier, the Canary Wharf Station was constructed using the TBM method. What we should pay more attention to here is that this station was built on water. But why was it constructed on water? For the Elizabeth Line to reach the Canary Wharf area, both underground space for the line and above-ground space for the station were required. However, the area was already filled with high-rise buildings, and even the underground was densely packed with subway lines and other underground infrastructure, leaving no available space for the new route. The only remaining option for Canary Wharf was the water, not land. The station had to be built on the water with space beneath it for the underground route to pass through. The development of Canary Wharf Station had a total budget of £500 million, with £150 million contributed by Canary Wharf Group, a UK real estate company. In addition, the group proposed developing the above-ground mixed-use facility with private capital, securing economic viability by combining public infrastructure with private commercial spaces. In fact, over 50% of the station construction costs were borne by the private sector. Building on a water body offers several advantages. First, construction can proceed without disturbing existing roads, sidewalks, or buildings. Additionally, there is less impact from vibration or settlement compared to construction on regular ground. The management of water pressure and water levels is more predictable, making the construction process more stable and safer. Lastly, when construction occurs after draining the water, noise, dust, and vibrations have minimal impact on the surrounding, which is a significant advantage in urban settings. To construct a building on water, it is crucial to assess the geological condition below the water surface. Just as when building on land, It is necessary to evaluate the condition of the ground and determine the construction method accordingly. To place a building on the ground below the water surface, it is essential to secure pipes, which makes the geological investigation even more critical. North Dock, with its 9-meter depth and the possibility of stabilizing the structure through ground improvement, met the necessary condition to support the construction of the building above it. This made a viable location for the Canary Wharf station. The first step in the construction process involved the adoption of a piling method. Concrete waterproof walls were installed to a depth of 30 meters, creating a box-like space. After securing this space and completely isolating it from the outside, the area was drained. This approach was chosen for its cost-effectiveness and safety, ensuring the structural integrity and the stability of the site. As part of the preparation for construction, dredging work was carried out to remove the mud, sand, and silt from the bottom of the dock. The purpose was to adjust the height of the dock floor to create a stable construction space. The soft mud layers were removed as they could cause the structure to sink. Afterward, a solid layer of sand and gravel was added to strengthen the foundation, creating a stable base for the structure. At the same time, floating bridges for construction were installed at the site. These are specially designed platforms that allow work to be carried out on the water, and they were essential for the construction process. Once these were in place, the actual construction work began. The first step in the process was to pump out the water from the cofferdam. To create a dry box area underwater where the building would sit, steel pipe piles were driven into the ground around the construction site, effectively separating the site from the surrounding water. Through the use of these piles, the water inside the enclosed box was drained out. To prevent future water inflow, the ground and walls of the cofferdam were treated with waterproofing. Interestingly, the piling process was not carried out on the southern side. Instead, the existing structures of the Canary Wharf area were used as a wall to seal off the southern space. After the water was drained from the space, the top-down method was applied to build the above-ground and underground level stations. Generally, buildings are raised from underground to ground, but this case, which has a small space and is waterfront area, was suitable for the construction building the ground first and digging the underground. However, not all of these construction processes were carried out sequentially. There were problems to be solved in the middle. The Elizabeth Line was the largest infrastructure project in Europe. It began in 2009, and 2018 was the expected opening date, but construction was delayed due to issues such as cost and COVID-19. Finally, it wasn't until 2023 that all of the lines could be opened. As a result, Canary Wharf Station was delayed too. The station's internal finishes and system installations were all linked to the overall Crossrail schedule, so delays in other sections of the line led to temporary suspensions of work. Next is issue of budget. Canary Wharf Station was physically completed in 2015, but with the repeated delays of construction, the station's opening was continually postponed. This resulted in over £200 million in additional costs due to equipment re-inspections, increased maintenance, security expenses, and temporary storage costs. Due to these issues, it took a full 13 years from the start of the construction before Canary Wharf Station could finally open. This week, we provided a step-by-step review of the construction process of the Elizabeth Line and the Canary Wharf Crossrail Station along with the challenges encountered. Next week, we will delve into the tunneling method used in the Elizabeth Line, specifically focusing on the TBM method. From week 5 to 8, we will explore the various construction methods applied during the development of Canary Wharf Crossrail Station. Then starting from week 9, we will discuss the materials, structural elements, and their applications in the project.